B3. Using the information obtained in question B2, the control charts, interpret the two control charts pertaining to process control. So you're going to make a comment here about the X bar chart and the R chart, but I'm looking for very specific things. In looking first at the X bar chart, I'm going to provide two examples here of the two extremes. One is you have an out of control situation. Now in reality it could be 1 point out of control, 2 points out of control, 3 points out of control, etc. Or it could be no points out of control, which means it's in control. So for this particular example here, I'm referring to this point being out of control, which exceeds the upper control limit, and this point being out of control because it exceeds the lower control limit. So I'm focusing on there and there. Notice I am not going to be talking about this point because it does not exceed the lower control limit. It's close, but it does not exceed it. So this is what I'm looking for in your answer with regard to a problem that has an out of control situation. You would say the X bar chart is out of control. You get a point for that because average measurements exceed the upper control limit right there at 6 p.m. and the lower control limit at 10 p.m. You get 2 points for identifying where. Continuing on, specifically we are 99.73% sure. You have to have that exact percent. It equates to essentially 6 standard deviations. So we are 99.73% sure that the process average has shifted. The process average has shifted. You get point for that. And we should investigate the root cause of the problem, +1 for stating that. Now, if you just throw a bunch of this stuff on there and it doesn't make any coherent sense, you're going to lose points, even if you have, 99.73. If it's spoken out of context or if it's incorrect in how you use it, then of course you're going to lose points. The next example regarding an X bar chart is one that is in control. If you had a situation like this where you had no points exceed the lower control limit or the upper control limit, you're going to have some language like this. The X bar chart is in control, +1 points if you have that correct, because no average measurements, these are the average measurements, exceed the upper control limit or the lower control limit. Again, 2 points for stating that it doesn't exceed either the upper or the lower. Specifically, we are 99.73% sure, +1 point for saying that the process average has not shifted, +1, and we do not need to investigate the root cause of the problem, +1. Moving on to the R chart. On the R chart, if you have a situation like this, you have a point out of control at the third measurement. And we'll say that the measurements occurred at 8, 10, and 12, so that would be the 12 p.m. measurement. So you would say this: the R chart is out of control, +1, because a range value, that value, exceeds the upper control limit at 12 p.m., or number 3. You get 2 points for where. Specifically, we are 99.73% sure, +1 point, that our process variation, not average, has increased, +1. And we should investigate the root cause of the problem. Like I mentioned in the videos on Chapter 9, is technically we would take action right at this particular point in time, not wait till the chart is plotted. But for our purposes in terms of interpretation, we just pretend like we are analyzing what somebody else has done. Let's look at the other end of the spectrum with regard to R charts where it's in control. You see that no points exceed this line and no points exceed the lower control limit. So you would say this: R chart is in control, +1 point, plus no range values exceed the lower control limit or the upper control limit, 2 points for saying that. Specifically, we are 99.73% sure, +1, that our process variation, again, has not increased. And we do not need to investigate the root cause of the problem. So that is what sort of analysis you would do for B3.